On October 18, 1989, the Space Shuttle Atlantis carried the Galileo spacecraft and its two-stage rocket into low Earth orbit. The rocket was released from the shuttle, moved to a safe distance, and fired, sending Galileo on a one-way trip to Jupiter. The orbiter had become the first known artificial satellite of the giant planet. The total cost of the mission was a little over $1.39 billion, which allowed the spacecraft to carry the latest devices to measure temperature, pressure, cloud particles, and atmospheric composition, as well as a probe targeted for deployment onto Jupiter's turbulent surface. The probe would provide the first direct sampling of the Jovian atmosphere and was a forerunner for future probes designed to explore the Sun and satellites like Titan with considerable atmospheres. The probe descended into Jupiter to analyze and directly sample its atmosphere, believed to be original material from which the solar system was formed 4.6 billion years ago. The Galileo mission, named after the Italian astronomer who discovered Jupiter's 4 large satellites, had been designed to use the gravity of those moons to bend the spacecraft's flight path during its 24-month tour of the Jovian system. As the probe sampled the Jovian atmosphere, scientific results were relayed to the orbiter for an hour before the probe's signal was lost at pressures of 10 to 20 Earth atmospheres. Galileo then made a close flyby of Io to study the moon's volcanic surface. Io's gravity, in turn, bent the trajectory of the spacecraft, helping to send it into orbit around Jupiter. Flying just 1,000 kilometers above the surface, images of the moon showed features as small as 50 meters. After relaying science data to Earth, the spacecraft orbited Jupiter 28 more times, making a close flyby of one of the Galilean satellites on each orbit, yielding high-resolution images, detailed measurements of their surfaces, gravity, and magnetic fields. As the orbiter rotates around Jupiter, the spacecraft sampled all regions of the planet. The first full orbit of Jupiter brought Galileo to its first encounter with Ganymede. The gravitational effect of the close equatorial flyby reduced the length of the spacecraft's orbit from 200 to 90 days. Using photographic data from Voyager, this computer-simulated flyby of Ganymede shows Galileo's view of the icy moon. Scientists now believe it has a frozen mantle 700 kilometers deep. Galileo flew even closer to Ganymede during its second encounter with the moon. Each satellite pass modified Galileo's orbit, sending the spacecraft onto its next encounter. Each flyby was 20 to 100 times closer than the Voyager encounters. Voyager saw only the equatorial regions of these icy moons, but Galileo was able to photograph the North Pole of Ganymede to provide a new perspective in the study of these large and distant satellites. The ancient cratered terrain of Callisto was closely studied as Galileo passed over the southern hemisphere of the outermost Galilean satellite. Unlike the other moons, Callisto seems more like a uniformly dense sphere, indicating that most of its rock and ice are mixed together. The spacecraft also swept within 200 kilometers of the surface of Europa at the end of its 8th revolution of Jupiter. Galileo's Europa encounters gave a first look at the moon's mysteriously fractured surface, seen by other spacecraft no better than we see Earth's moon through a small telescope. During its extensive mission, Galileo expanded our knowledge of Jupiter and the 17 diverse worlds in orbit around it, revealing in detail the bodies and workings of this miniature solar system. And best of all, Galileo is really just at the beginning of all that's humanly possible.